Hi guys, welcome to my channel Sushruta. Today our topic is on classification of halogen compounds. First, what is halogen compounds? A hydrocarbon which is attached with a halogen, a single or many halogens, is known as a halogen compound. Those halogen compounds can be classified by the below characters which are being discussed now. First, the halogen compounds can be classified based on number of halogen atoms. That means they can be classified based on the presence of number of halogen atoms. See, first monohalogen compounds. The name itself refers mono means single. If single halogen is present, then that particular compound is known as monohalogen compounds. See, methylchlorine or chloromethane and bromoethane. These are the compounds with single halogen. So these are monohalogen compounds. And the other, dihalogen compounds. That means if two halogens are present, then that particular compound is known as dihalogen compounds. CH2Cl2. Trihalogen compounds. If three halogens are present, then that particular compound is known as trihalogen compounds. CHCl3. It is also known as chloroform. And tetrahalogen compounds, finally, because the carbon has a tetravalency, right? So CCl4, carbon tetrachloride, or tetrachloromethane. Based on the number of halogen atoms, first of all, the halogen compounds are described like the above I said. Next, the halogen compounds even can be classified depending on nature of carbon atom to which the halogen is attached. That means here the halogen is attached to the primary carbon. So this particular compound is known as primary halogen compound. Primary carbon means the carbon which is attached with a single carbon group is known as primary halogen compounds. So this particular halogen is attached to the primary carbon. So this compound is known as primary halogen compound. Next, secondary halogen compounds. That means the carbon which is attached with two carbons, then that particular carbon is known as secondary carbon. If a halogen is attached with a secondary carbon, then that particular compound is known as secondary halogen compound. 2-chloropropane is the best example of secondary halogen compounds. It is also known as isopropane. Tertiary halogen compounds. Tertiary means the carbon which is attached with three other carbons is known as tertiary carbon. This is tertiary carbon to which the halogen atom is attached. Here the chlorine is the halogen which is attached to the tertiary carbon. So this compound is known as tertiary halogen compound. 2-chloro-2-methyl-propane is the IUPAC name, or it is also named as neobutyl chloride. Butyl because presence of 4 carbon atoms. Next, even vinyl halides and allyl halides are being classified. These vinyl and allyl halides are only being classified on the basis of alkenes. Only for the alkenes, the vinyl and allyl halides are specified. Firstly, what is vinyl halide? Halogen attached to the sp2 hybridized carbon is known as vinyl halide. That means, look, here the halogen is attached to sp2 hybridized carbon. Here double bond is present. So this carbon is sp2 hybridized. sp2 hybridized carbon. So this particular compound is known as vinyl chloride or vinyl halide. Here any halogen can be used. This IUPAC name is chloroethene. Ethene, presence of double bond. Okay. And next, allyl halide. Halogen attached to the sp3 hybridized carbon which is attached to sp2 hybridized carbon. Don't get confused regarding this. While looking at the examples, we could be understood better. See, here, this is the sp3 hybridized carbon and this is sp2. Here, the halogen is attached to the sp3 hybridized carbon, which is attached to sp2 hybridized carbon. So that particular compound is known as allyl halide. Allyl halide. The vinyl and allyl halides are particularly seen in alkenes. Remember, it's an important point. Next, aromatic halogen compounds. What are aromatic halogen compounds? Aromatic means cyclic ring structures. Halogen compounds means the compounds in which the halogens are present. First, these aromatic halogen compounds are differentiated into aryl halides and aralkyl halides or aryl alkyl halides. You can pronounce it in any way. Generally, aralkyl halides are preferable. Firstly, aryl halides. Halogens are directly attached to the aromatic ring. That means the halogens are directly attached to the carbon which is present in the aromatic ring. See, here the chlorine is directly attached to benzene ring. So this is chlorobenzene. It is an aryl halide. This is a good example for aryl halide. And see, this is, here the chlorine is even attached directly to the benzene ring. You can ask me, why have you written that orthochlorotoluene? Because toluene is more stable than chlorobenzene. So, this chlorine is attached to at the ortho position of toluene. That's it. Don't get confused regarding this example. And see, next, aralkyl halides or aryl alkyl halides. Halogens are attached to the substituent carbon chain of the aromatic ring or substituent carbon is known as aralkyl halides. See, basing on the name only we can say aryl means aromatic ring, alkyl means alkyl chain, and halides as usual the halogens. So look, one chloro, one phenyl methane. This will be the main one and these are the substituents. This is a perfect example for aryl alkyl halides. Next, dihalogen compounds. As I said before, dihalogen compounds means the compounds in which two halogens are attached. These dihalogen compounds are differentiated into geminal dihalides, vicinal dihalides and omega dihalides. This is the symbol of omega. Let's see. This is the final topic in classification of halogen compounds. First, geminal dihalides. If two halogens are present on the same carbon, then that dihalide is known as geminal dihalides. See, here the two chlorine atoms or either fluorine-chlorine or fluorine-bromine or chlorine-bromine, anything. If two halogen atoms are attached on the same carbon atom, then that particular dihalide is known as geminal dihalides. So this 1,1 dichloropropane is geminal dihalide. Next, when it comes to the vicinal dihalides, if two halogens are attached to the adjacent carbon atoms, see the carbons which are adjacent to each other. If such the halogens are attached to two carbon atoms which are adjacent, then that particular dihalides are known as vicinal dihalides. See here 1,2 dichloropropane is a best example of vicinal dihalides. Omega dihalides. If two halogens are attached to the two terminal carbons of the extreme ends, look here, the two halogens are attached to two terminal carbons, then such dihalides are known as omega dihalides. Here in the place of n, you can, if you keep 1, then it will be the propane chain. If you keep 2, then it will become the butane. If you keep 3, then it is pentane. That's your wish. But the two halides will be attached at the extreme terminal carbons. Then such dihalides are known as omega dihalides. That's it for today, guys. If you like this video, please like, share and subscribe to my channel Sushruta. Thank you. Meet you in the next video. Bye bye, guys.